Okay, so let's solve question 4.11 or 4.11 from the Bhag textbook. So this one is a simpler problem. If you have watched problem one, it will become extremely simple to understand. So we have a 200 kVA transformer with a core loss of 10 kilowatts and a copper loss of 40 kilowatts at full load, right? So this is at full load. What is the kVA rating at the maximum efficiency of the transformer? Express the load current at maximum efficiency as a percentage of the rated current. Okay, we can do that. If the transformer operates at a power factor of 0.8 lagging, determine the maximum efficiency and B, the full load efficiency of the transformer. So there are actually lots of questions here. So the first one we have to answer is the kVA rating at the maximum efficiency. So what is going to be S max? S max is given to us as S full load multiplied by PC over PCU. And we have discussed before that this square root of PC over PCU is what we also refer to as N, right? So that's like percentage of the load. So this is the percentage of the load. So PC is given to us as 10 and PCU, which is the copper loss, is given to us as 40 kilowatts. So that means we already know the value of S max. So in this case, S max is equal to S full load, which is the rated. So S full load is what we also refer to as the rated kVA, which is 200 kVA multiplied by 10 divided by 40, right? So 10 divided by, since it's kilo and kilo will cancel out, so that's why I'm not even paying attention to that. So this is about 1 over 4. Can you see? I think the mathematics here is easy. So this is 1 over 4, which becomes 200 divided by 2, right? So this is 100 kVA. So that one is done. So now we know the S max. And we can find, now that we know the S max, now we can find, what else can we find here? So they say express the load current at maximum efficiency as a percentage of the rated current. So the load current at maximum efficiency is what we call you can just call it I max, right? And how do we get I max? I max is nothing but the voltage, right? So we can get it as the voltage and then S. So this is N multiplied by the value of N. So S times N, and this is your full load value. So S times N is what we have seen before as this, right? Is the value of S max, and that we have already found. So we can find this S full load, S max. So this is equal to S max divided by V, right? And this V, this is of the load, right? So this is the V of the load. And for most circuits that we're given, we call this Vs prime, right? So we call this Vs prime because it's the load voltage referred to the primary side. Okay. and and it's a value that is not given, but because we are just asked to express this as a percentage, I think you can already see that this thing will disappear. And the full load the full load current is IFL, which is given as I as S full load divided by Vs prime. So if I do the division, if I say IM divided by IFL, then this will be S max divided by Vs prime times, because it's division, right? So this is going to be times Vs prime divided by S full load, right? And overall, we have that the percentage IM over I full load is nothing but S max divided by S full load, right? So if I take my calculator to solve this, do I need a calculator? Let me see. S max is 100 kVA. S full load is um, is 200, right? I hope you can see. S full load is what we're given. So this is 1/2, which is in percentage 50%, right? So now we are done with that portion of the question when they say write the load current at maximum efficiency as the percentage of the rated current, right? So the rated current is the full load current. Okay, now let's start solving these things. The maximum efficiency. So how do we find maximum efficiency? Let me write the formula down. So maximum efficiency for A, we call it S max. Ah, no. Maximum efficiency, we call it this symbol max. I forgot the name of the symbol. I think it's called uh, eta. Maybe it's called eta in Greek. Maybe it's eta, the symbol that we use for efficiency. So this max is equal to S max times the power factor divided by S max times the power factor plus PC plus PCU. And the concept is that at maximum efficiency, PC is equal to PCU. So what we do is this PCU is is variable, right? This PCU is variable. This PC is a constant value. So since this PCU is variable, so we can adjust PCU such that it is equal to PC. So that's why when we are dealing with maximum efficiency, what we do is we just call these two guys, since they are the same, you just call it 2PC, right? So we adjust PCU such that PCU is equal to PC for maximum efficiency. And then I multiply this by 100. So in this case, we have S max already, which is 100 kVA. Is 100 kVA. So since everything is in kilo, I see that if we look up, everything is given to us in kilos, so I don't need to call it 100,000. So I just call it 100. So this is 100, and the power factor is 0.8, because they say that if the transformer operates at a power factor of 0.8 lagging, determine the maximum efficiency. So it's 100 times the power factor. Sorry, it's 0.8 now. 0.8 divided by 100 times 0.8, and then we add this to 2 times PC. Now, let me re-explain this. You see, here, the core loss is 10 kilowatts, and the copper loss is 40 kilowatts. So and the copper loss is 40 kilowatts. So which one do we choose? Do we choose the 10 or do we choose the 40? So the concept is that we are going to adjust this guy such that it is equal to this guy. So basically the value that we are going to choose is always the value of PC. because that's the constant value, right? So then I have 2 times 10, right? 2 times 10. Let me just use the black color, 2 times 10. And then I'll multiply by 100 so that we get the percentage. Okay, so take my calculator. I have 100 times 8, times 0.8, which will give me 80. So that's same answer divided by answer plus 2 times 10 times 100, right? Now the 100 is multiplying the whole thing for me to change into percentage. So my percentage is 80%. So I'm getting a value of 80%. So the maximum efficiency in this case is 80%. 80%, sorry. 80%, right? So this is the maximum efficiency. Now, the full load efficiency of the transformer, remember, if this is the maximum efficiency, we expect the full load efficiency of the transformer to be lower, right? Because this is the maximum one. So the full load efficiency, which I'm going to call it eta FL for full load, is equal to S full load times the power factor divided by S full load times the power factor plus PC plus PCU. Okay, now S full load is the rated apparent power. In this case, we were given 200, right? So this is 200. And the power factor was given to us as 0.8, right? So this is 0.8. So I'll just multiply this by 100 so that we get in percentage, right? So then I have 200 multiplied by my 0.8, which is the power factor. My 8 is never great. And I'll repeat the same thing, 200 times 0.8. Now, the value of PC is, they are no longer the same. I hope you know. No? They are only the same when we are dealing with the maximum efficiency. The value of PC was given to us as 10, right? And the value of PCU was given to us as 40, right? So those are the values that we are going to use if we are dealing with efficiencies that are not at maximum, right? And then I multiply this by 100. So now let me take my calculator and see what I get. I expect to have something lower. If I get something higher, something is wrong with me, right? 200 times 0.8, which I'm going to get at 160. So I have that answer divided by answer plus 10 plus 40, which is 50. And then I'll multiply that by 100. And I'm getting 76.2%. So this is now 76.2%. Now you can see that this value is lower than the maximum efficiency. So therefore, I have done something correct, right? I have done something correct. Okay, so this is all we had for this problem. It is a very straightforward problem if you have checked the first video that I recorded on this series. Thank you very much for your time.